So I'm going to use this to illustrate what partial fraction decomposition means. So in order to add these two, we have to get the same denominator. So times by 3x here and times by 5 here, 5y over here. So once you times by both sides, you get 10y over 5xy, and then 4 times 3, 12x, 5 times 3, 15xy. So now you have a common denominator for both. Then you're going to add these two. Once you do that, you get 10y plus 12x over 15xy. So that's how you usually solve this kind of question. So what partial fraction decomposition allows me to do is take this single fraction and break it down into two simple fractions. So that is what partial decomposition means. So the first row would be an example of linear factors, x plus 2, 3x minus 5, or even x. And this is an example of a quadratic factor, same as this. So these cannot be factorable. Those are examples of quadratic and linear factors. So how would you describe this term over here? This term is actually a repeated linear factor. As you can see, it has a square. And this term over here will be an example of a repeated quadratic factor. So let's start with our first question. So here's our question, and we have to use partial fraction decomposition. So first thing you do is you have to factor out the bottom. You factor out this. Once you do that, you get x minus 2 and x minus 5. Now I'm going to rewrite it and split the two terms. So it becomes x minus 2 plus x minus 5. Now every time you have a linear factor in the denominator, you have to put a constant up. So I'm just going to use a and b. So a and then b. So what I did now is I just rewrote this and this over here. So our goal is to determine what is your value of a and what is your value of b. So the first thing you're going to do is you're going to multiply all of this by x minus 2 times x minus 5 over here. So when you multiply this with this cancels, okay? And then when you multiply x minus 2 and then x minus 5 with this, x minus 2 cancels. And when you multiply this with this, x minus 5 cancels. So I'm going to rewrite that. So as you can see, your bottom will cancel because they're both the same. So you get 7x minus 23, which equals, again, x minus 2 and x minus 2 cancels. So you're left with 8 times x minus 5. The same thing happens here. X minus 5 cancels, so you're left with x minus 2. So that's how you rewrite it. So now there's many ways in order to find your a and b. But what I'm going to do is I'm going to plug in x values for a and b. So the first one I'm going to plug in is x equals 5 over here. And the second is x equals 2. So now I'm going to use x equals 5 from here. So once you plot in 5 for all your x's in this equation, you get 7 times 5 minus 23 equals a, 5 minus 5 plus b, 5 minus 2. So when you equate this, you get 12, and then 5 minus 5 is 0, so that's cancelled. So you're left with b times 3. Then divide 3 on both sides, so you got b equals 4. The same thing for x equals 2. So I'll plot in 2 into the whole equation, and then once you do that, you get a equals 3. So where did I get my x values from? From the equation. So over here, when I say x minus 5 equals 0, and you try to find your x, you get 5. And then when I say x minus 2 equals 0, when you try to find your x again, you get 2. That's where I got my x values from. So now you have your b and now you have your a. I'm going to rewrite it. So we figured out that this becomes that. And now that we have our a and b, we can plot it into here. So once you do that, you get 3, because a is 3, x minus 2, and then plus 4, because b is 4, over x minus 5. And that's basically how you answer that question. So from that to that. Okay, so now we know the basics of how to answer using partial fractions decomposition. So now in the book we have question 4, and it's a bit different because it includes an integral. Now the steps are really similar, it's just that you're dealing with an integral. So now the first thing we're going to do is we're going to split it and find the factor of the bottom denominator. Once you do that, you get 3x minus 1 and 3x plus 1. So this is how I rewrote it. Again, you split the 2 and you put it over constants, so a and then b. So for now, let's just ignore the integral and remove it, including dx. And we're going to answer it like we did it before. So now that you have that, we're going to multiply it by 3x minus 1 and 3x plus 1. So I'm going to multiply all of that by 3x minus 1 and 3x plus 1. So here, I'm going to multiply it, this cancels, so you're left with 2. Here, 3x minus 1 and 3x minus 1 cancels, so you're left with 3x plus 1. So 3x plus 1 times a. Here, 3x plus 1 cancels, so you're left with b, 3x minus 1. So here, I rewrote it as 2 equals a times 3x plus 1 plus b, 3x minus 1. And again, here we need to find the a and the b. So you need to find your x values. So if you don't know how to find the x values, what you do is you put in these two equals 0. So 3x plus 1 equals 0 and 3x minus 1 equals 0. And then once you isolate x, you get x equals negative 1 over 3 and x equals 1 over 3. Okay, so once you plot in your negative 1 over 3 and 1 over 3 into the equation, so for example, here becomes 2 equals 3 times negative 1 over 3 plus 1 plus b, 3 times, replace your x value, negative 1 over 3 minus 1, so you get b equals negative 1. Do the same thing over here, and you get a equals 1. So now you have your b, and now you have your a, and you're going to plot it in here. So now that you plot in your 1 and your negative 1, you get this. And now from here onwards, you're going to have to integrate as usual. So now we're going to integrate this. So what we're going to do is we're going to take the substitution method and we're going to use u. So we're going to use u equals 3x minus 1, and then du becomes 3 dx, and then since there's no 3 here, you divide by 3, so you get du equals du over 3. Then we're going to rewrite that, substitute it here, it becomes du over 3 over u. We're going to take 1 over 3 out, so we're left with du over u. Du over u equals ln u. So 1 over 3 ln u. And then what is your u? 3x minus 1. So it becomes 1 over 3 ln 3x minus 1. Now, for the second one, you'll do the same thing. Substitute in method, and then, so you find your u, then you find your du, substitute your u and du into the equation. So that's that. And then you do the same thing you did over here in the first step. Instead, this one is negative. So it becomes negative 1 over 3 ln 3x plus 1. Then you're going to combine the two terms because it is addition, as you can see. Once you combine the two terms, it becomes 1 over 3 ln plus c. Don't forget to c because it's an indefinite integral. Then using the properties, this can become 3x minus 1 over 3x plus 1 because ln A minus ln B, so ln A is basically A, minus ln B equals ln A. Now from question 21 to 24, we are dealing with definite integrals. So we actually have your intervals from 0 to 2. Now I won't be solving step by step for this question because it's similar, but I will jump to how we're going to use it with 0 and 2. So those are the steps I did. So once you've done all of that, you come here. So now you have your B and you have your A, and you can now integrate. So again, you find your U and your DU. Once you do that and you integrate, you get ln 4x plus 1. And now you're going to use your 2 and 0. So you're going to substitute 2 into x and 0 into x. The same thing for this. You're going to find your u and du, and then you're going to substitute your 2 and 0. So once you substitute your 2 and 0, I get ln 3 plus ln 1 plus ln 9 minus ln 1. So as you can see, ln 1 and negative ln 1 can cancel. So you're left with negative ln 3 plus ln 9. And then using properties, it becomes 9 over 3. 9 divided by 3 equals 3. So that's your final answer. So similar process, it's just that you're gonna have to substitute your 2 and 0 into the equation. Okay, from 25 to 32, we're dealing with trigonometric functions. So here, it's a bit different to the steps. Instead of directly finding your denominator, we are going to substitute u and du. So we're going to find our u and our du. Then we're going to rewrite it as negative du. And then since cos is u, becomes u plus cos square from the question. Now, once you do that, you find your denominator. So you find your two terms, and that is u times 1 plus u. Then you're going to split it like I did here. And now you're going to find your a and b. Once you find your a and b, I'm just skipping steps here because the video is already long. So I find negative 1 and 1. Then you're going to substitute a negative 1 and your 1 into your equation from here. And then you're going to integrate. Negative 1 over u is basically ln u, and then here again it becomes ln u plus 1, and then don't forget your c because this is indefinite. And then using the properties, it becomes u plus 1 over u, and then now your u is cos x, so you're going to substitute your u into the equation, and you get ln cos x plus 1, and then over u, which is cos x, and then plus c. So that's how you do 25 to 32.